Welcome to our Mathematics Form 1 class, and we are still on the topic of common solids. And today we are in the subtopic of nets of solids. I am your presenter, Mr. Nderitu, and let us start with today's objectives. The first objective, you should be able to define a net. Next, you should be able to draw sketches of common solids, for example, a cuboid, a cube, a square-based pyramid, a cone, and a cylinder. We can define a net as a cutout frame from which a three-dimensional figure is made from. With me, I have an example. I am holding a carton that has been made by a manufacturer, and this is a three-dimensional figure. How do we define a three-dimensional figure? It must have the following. It must have the height, the width, and the length defined as I'm holding here. If it doesn't have these three planes, then we cannot call it a 3D figure. So for you to make this shape, which happens to be a cuboid, the manufacturer must first of all come up with a net, join it so that he can create the cuboid that I'm holding here. I have other samples. This is a small box, and this is an even larger box. All these are made using nets, and I would like us to look at which are the two main shapes, starting with the cuboid. So let me start with the cuboid and illustrate how to draw a net. So I have sketched what I'm holding on my hand, on my board here, and it is a good example of a cuboid. And I'm going to open it up so that you can try to understand how it was made about. And as you can see, it sticks on a surface because from the plane, when you fold the plane or the sketch, that's when you make a 3D figure. You must start with a sketch or a net, and from there you fold it up to make a cuboid. So the first thing, we need to look at the number of faces. A cuboid has a total of how many faces? 6. And as you can see, I have labeled the first 4 here, and I'm going to start by drawing the first 4 faces. Remember, these are the ones that are folded together to form the curved surface area. Those are my 4 faces, and I must make sure that the length of this cuboid corresponds with the length of the faces that I have drawn. I am remaining with 2 faces. The first one is the front part. The other one is hidden at the back side of my cuboid. For this one, you are allowed to draw them on any face. I can choose to draw the front one next to the face number 2, and the back one next to the face number 4. Either way, as long as the two faces are on opposite sides, then then you are sure that once you close the sketch, you are going to have a complete cuboid. The next thing, apart from the faces, we must make sure that the measurements correspond. If they don't correspond, we might end up with a cuboid which is not as we had expected. Maybe a smaller cuboid or a very large cuboid, like the one I have here. For the case of the measure, I started by saying that this length must correspond with the length on the first, second, third, and fourth face. Another thing, the length of the front and back faces must correspond with the size or the width of each of these faces. For example, if the length was 5 centimeters by 5 centimeters, I must make sure that each face is having a width of 5 centimeters. If it doesn't have a width of 5 centimeters, I shall not be able to cover it up when I come to joining them. So the length of this small face here must be equal to the length of this part which is in that cuboid. Don't worry about these other hanging parts. These are just flaps. And the flaps are where you place your glue so that the carton can fit together. So the flap that you are seeing here is not part of our sketch. But in case you are making one so that you can have it maybe as a box, as this example, you will require to leave some space for the flaps. This way you apply some glue and then you stick it to form a complete cuboid. We go to the second type of a solid and see how its sketch is. We are still looking at nets of common solids, and previously we have just looked at the cuboid. Now we are in a cube, not to be confused by a cuboid. When you look at a cube has equal sides. The length is the same for all the sides or all the faces of a cuboid. So step one, we start with the expected number of faces. The faces are expected to be 6. And because the shape is a regular shape, the faces happen to be all squares. So the first step, I will start by the curved surface area. It has a total of 4 squares. That's a total of 4 squares. That caters for the curved surface area. Remember, we said the length must be the same on each side of each face. If they are not the same, what we end up with is not a cube, and we might even end up with a cuboid. The next step, remember the faces are 4. So I'm remaining with 2 faces that I use to close the sides of the cube. I am free to draw them on either of these faces. Remember, they must always be on opposite sides. That is the front face of our cube. I am remaining with the back face of the cube. I am free to draw it as long as it's on the opposite side of the front face. So I can even draw it on face number 4. All I need to consider is the length of that face should be the same all through. That's the only way I can end up with a cube. And with that, this can be a sketch that when cut out from a small cardboard, it can form a shape of a cube. Next, we go to another common solid. This is still on the topic of nets, and we are looking at the third type of a common solid that you can make using a net. Remember, for you to make a carton, for example, the one that is used to sell milk, we require to have a sketch, and from the sketch, once you join it, that's where you create a solid. For example, we are looking at a square-based pyramid. When you want to make a net, we have said step 1, you must consider the faces. My example has 5 faces. However, unlike cubes and cuboids, the faces are not of the same shape. For example, there are 4 triangles that are attached to one square. And that's why we call it a square-based pyramid. The base is a square. Let us start with drawing the base, because from the base, that's where all the other triangles are connected to. That is our square base. So I always start with the base. Next step, I now draw the 4 triangles. Remember, each is attached to the base. Having done that, I just need to transfer the measurements. For example, if the sides of the triangle were having a length of A, I must make sure that each of these triangles is having a length corresponding to A. Another thing, if the square was having a length of B, I must make sure that the length of my square is also in B units. Having done that, I am sure that if I cut this cardboard and join it together, I should end up with a square-based pyramid that I can put some milk or any other object in it. We go to the 4th type of a common solid. We are still looking at solids and how we make solids using the net. So far, we have been able to look at cuboids, cubes, square-based pyramid, and now we are looking at another common solid known as a cone. I know we have interacted with a cone. Maybe when you are having your snack, maybe an ice cream, and we know the shape of a cone. We also have some beautiful hats that are made during parties where you can wear a cone shape, and we want to see how do they design these cones. A cone is a kind of a special pyramid that has the base as a circle. Step 1, we consider the faces. A cone has 2 faces. Number 1, it is the circle that is also the base. Number 2, we have a curved surface which many students confuse with a triangle, though it's not a triangle, and we are going to see why. So I start by drawing a circle, making sure that the radius corresponds with the radius of my cone. Step 2, the curved surface area that I was telling you about happens to be a sector of a circle. Remember, when you are having your chapatis at home, you can get a slice of a chapati and this piece is what we call a sector. So the curved surface of a cone is a sector with number 1, an arc, and the size of the arc must correspond with the perimeter of our circle. If the arc does not correspond with the perimeter of our circle, then the cone shall not be fully covered. Therefore, I shall come and join a sector, and when it is cut out, it should end up having the length of this arc corresponding with the circumference of my circle. We have a sand height L, which is different from our perpendicular height H. When you are drawing the net that is drawn or cut out here does not correspond with the height. It should correspond with the slant length. Slant length. Therefore, when we come to make the net, it is made up of a circle and a sector. And that's how we draw the net of a cone. We are still on the topic of common solids, the subtopic of nets. And so far, we have looked at how to sketch the nets of common solids like a cuboid, a cube, a square-based pyramid, and a cone. Today, we are going to look at a cylinder. We have been having drinks using cups. We have been writing with pens that are in cylindrical shape. And today we want to look at if you want to design a small box that is cylinder in shape so that you can pack your cup, what do you need as a sketch? So step 1, we always start by defining the faces. How many faces do we have in a cylinder? We can say there are 2, however, the 2, one is a curved surface, the other 2 are circles. So 1 curved surface and 2 circles. We shall start by drawing the curved surface. We notice that when you have a small tissue roll, maybe you want to visit maybe the loo or the toilet. The roll comes in the shape of a cylinder. However, when you open the cylinder, you end up with rectangular shapes because the curved surface of a cylinder happens to be a rectangle, where the length or the height corresponds with the length of our rectangle. So the length here corresponds with the length of that triangle. Next, the width of the triangle corresponds with the circumference of this circle. It corresponds to the circumference of one of these circles here. I'm almost finishing the cylinder, but I require the 2 faces that I used to cover. I am free to draw them depending on which shape I am using. For the first case that I have drawn, for this one I can draw them on this side. and the other one on this other side. For this case that I have here, I can draw the two circles, one on top of the other, but remember, this time round, the length here shall correspond with the circumference. That is for this diagram. However, for this case, the width is what will correspond with the circumference. So you need to be careful on when to use the length as the circumference here or the width as the circumference. In both cases, the cylinders should come back to the same shape. As a recap of what we have done,